Hello all, in today's class we are going to discuss one more important topic in transactions, that is implementation of isolation. Let us first define what an isolation is. In the previous class we have defined the properties of transaction, namely atomicity, consistency, isolation and durability. Isolation is one of the core property of the transaction, and it is ensuring that the operations of one transaction remain hidden from other transactions until completion. What do you mean by this? Whenever concurrent transactions takes place, execution of one transaction must not be interleaved by the execution of another transaction. So that is being ensured by a property called isolation under transaction management. Now we have the other point, that is isolation levels define the degree to which a transaction must be isolated from the data modifications made by any other transaction in the database system. Here we have different levels of isolations, and every level of isolation will define to what extent the transaction must be separated from the data modifications that it has made by any other transaction in the database system. Four levels of transaction isolation we have, namely serializable, repeatable read, read committed, and read uncommitted. Now let us see what is serializable. Serializable is the first level of the isolation. You can even say that it is the highest level of the isolation, and it is going to guarantee the full serializability and ensures the complete isolation of transaction operations. So which means when multiple transactions are executing, this particular level of isolation will not allow the other transactions to interleave or execute at the same time when one transaction is under the process. That is about the serializing. And next, coming to repeatable read. Repeatable read says that this is the most restrictive isolation level. It is because this kind of transaction will hold read locks on all the rows it references. So whenever it performs a read or write operation, it is going to hold the lock. So when locks are acquired by one transaction, then it will not allow the other transactions to process or access the same data item at the same time. All the other transaction cannot read, update or delete these rows. It avoids a conflict called non-repeatable conflict. Non-repeatable conflict or non-repeatable read. So this kind of problems can be avoided whenever the transaction holds lock to perform a read or write operation. That is about the other level of isolation. Next, let us see what is read committed. This isolation level allows only the committed data to read. So by this statement itself, you can understand thus, it does not allow any dirty read. What is dirty read? This is again one of the conflict which we face when multiple transactions execute concurrently with each other. Right. So dirty read says that one transaction reading of data immediately after it is written by the another transaction. That is when the other transaction does not perform any commit. Before commit, if the other transaction is reading the value which is written by the first transaction, then it leads to a dirty read. And coming to the read uncommitted. What is read uncommitted? It is the lowest isolation level. In this level, one transaction may read not yet committed changes made by the other transaction. Now, what is the meaning of this? This level allows the dirty read. In some or other cases, if there causes any internal failures, then it requires the failed transaction to be rolled back. So if that particular transaction is rolled back, then the operations made by the second transaction must also be rolled, as it has read the data which is not committed. Now let us see what is the implementation of isolation. Implementing isolation typically involves concurrency control mechanisms. What is concurrency control mechanisms? Why do we need a concurrency control mechanism is to ensure the consistency of the data and integrity of the data in the database. Like locking mechanisms, and we have timestamp based protocols. Under locking mechanisms, we have three different types. One is S-lock. S-lock is nothing but it is a shared lock. And the other one is X-lock. It is also known as exclusive lock. And the last is 2PL. 2PL refers to two-phase locking protocol. So firstly, let us see what is a shared lock. Shared lock will allow a transaction to read an item but not write to it. Any transaction which wants to perform a read operation, it has to acquire the shared lock. It is a lock which is been acquired by the transaction. And any transaction which holds this S lock is allowed to perform the read operation. Clear? So this is the read operation, but not a write operation. And coming to exclusive lock, which is also known as X lock. This is going to allow a transaction to read and write an item. Here it is going to perform only read, and here it is going to perform read or write an item. Read and write an item. So no other transactions can until read or write until the lock is released. And next coming to two-phase locking. What is two-phase locking? This is a protocol which is going to ensure that the transaction acquires all the locks before it releases any. That means this results in a growing phase and shrinking phase. Under 2PL, we have two things. What is growing phase and what is shrinking phase? As said before, this protocol will ensure the transaction acquiring all the locks before it releases any. This is going to result both the phases. One is growing and the other one is shrinking. Growing phase says that acquiring the locks and not releasing any. The transaction will acquire the locks to perform either read or write operations on some data item, but it is not going to release any. And coming to shrinking phase. Shrinking phase is what? It is releasing the locks. It is releasing the locks and not acquiring any. When operations on particular data item made by the transaction is completed, then it is going to release the locks. Later on, it is not going to acquire any of the locks. And that is known as what? It is a shrinking phase. And coming to the timestamp protocols. Transactions can only access the database if they respect the timestamp order, ensuring the older transactions get the priority, which means every transaction, it is assigned with some unique timestamp. I'm going to write here. Unique timestamp. It's nothing but some ID. Here, every transaction has got some unique timestamp. And then whenever it is going to start with its execution, it will follow the order of the timestamp. So this timestamp simply, what can we say, that it is going to determine the order of the transactions. And the transactions can only access the database if they respect the timestamp order, ensuring what? The older transactions get priority. Whichever transactions has come first, the execution of those transactions must be completed, and then based upon the order of the timestamp, the other transactions should start executing or performing operations on the same data item if they wanted to access. This is about the different levels of isolation.